Hello my dear students, welcome to IMS GATE Academy. Myself Sandeep Adari with 10 plus years of experience in GATE. My dear students, today I am here to discuss about the most important topic on soil mechanics, that is ATTERBERG limits. In the previous sessions we have discussed about the properties of soil, and in today's session I would like to discuss what do you mean by ATTERBERG limits. So before starting the session, what we do at IMS GATE Academy. My dear students, IMS GATE Academy offers 800 plus hours of GATE coaching. And the biggest news coming together is students who have secured a good ranks in GATE 24. Definitely, if you want to look for any post-GATE guidance, you can join our Telegram group. Let us see the silent features of IMS GATE Academy. We offer 800 plus hours of GATE coaching. It can be online, it can be self-recorded, or it is offline. We offer offline GATE coaching at Jayanagar and Malleshwaram. My dear students, we are the only institute in Andhra Pradesh who is providing the offline GATE coaching at Vijayawada near Bund Circle. Why we are most appreciated? Because see students, we provide subject-wise material, we provide exercise book which contains level 1, level 2, level 3 questions. And remember, it includes MCQs, NITs and MSQs also. And the GATE question booklet, which is highly appreciated, we are containing 34 years of solutions, 34 years of previous year GATE solutions. Along with that, we are giving you key pointers, alternative solutions, and wherever the difficulty level questions, we are providing the online recorded problems. And apart from this, why IMS is highly appreciated is, we are providing one-to-one mentorship. In mentorship, how the weakness can be converted into strength. We'll be discussing the entire roadmap for the year of preparation. And remember, we are also providing doubt solving portal which can be resolved within 24 hours of time. Apart from this, testing yourself at every stage is very important. You want to test at chapter level test, you are providing chapter level test. If you want to test at subject level, we are providing subject level test. If you want to test at advanced level, we are providing advanced level test, multiple subject test, and we are also providing you the all India mock tests, which will be a replica of the GATE environment. Now let me tell you one important thing, my dear students. Have you secured good results in GATE 24? Then join our Telegram group. Are you looking for the post-GATE guidance? Are you looking for an interdisciplinary branch in IIT Madras or IIT Delhi? Are you confused? Are you a civil engineer and you want to join computer science? Do you want to verify all your queries? Then join the Telegram group. In the Telegram group, we will be giving you all the solutions. We at IMS GATE Academy has a team of mentors who have secured their PG or post-graduation from IITs and NITs. So it's my sincere request, like we have heard from some of the other branch students, how to apply for interdisciplinary. Anyhow, we have done the post-grad guidance with uploaded videos in our channel. Apart from this, if you want to understand yourself, you can join the Telegram group and get in touch with the respective mentors. So I don't want to waste your time, and let us understand the most important topic, that is ATTERBERG limits. We are going to study what, my dear students? ATTERBERG limits. So what do you mean by ATTERBERG limits? So here let me tell you, my dear students, ATTERBERG limits are also known as consistency limits. What are ATTERBERG limits, sir? ATTERBERG limits are consistency limits. And immediately, my dear friends, you will ask me, sir, what is the purpose of studying ATTERBERG limits? The purpose of studying ATTERBERG limits is, this will help you to classify the fine-grained soils, and it is an indication for shear strength. To understand the shear strength of the soil, we should require some plasticity characteristics. Similarly, if you want to classify the soil, we should know some plasticity characteristics. All these can be studied in the ATTERBERG limits. So we have a chart here, students. Let me explain you the chart. One second, students, let me draw the diagram. Now see students, a graph is drawn between water content and volume, okay? A graph is drawn between water content and what, sir? Volume. We call this point as shrinkage limit. This is plastic limit and this is liquid limit. Okay, we call this state as solid state. This is semi-solid. This is semi-solid. This is plastic state. And this is called liquid state. Okay, now let me understand you, my dear students. What do you mean by ATTERBERG limits? My dear students, ATTERBERG limits are nothing but the contents. These are the water contents at which soil passes from one state to the other state. Agree? See, that is the beauty of this. So, my dear students, you can write a note here. ATTERBERG limits are the water contents at which soil passes from one state to the other state. Now, if the water content is above liquid limit, it is liquid state. If the water content is between plastic limit and liquid limit, then it is plastic state. If it is between shrinkage limit and plastic limit, then it is semi-solid state. Below shrinkage limit, then it is solid state. So, first of all, my dear students, ATTERBERG limits are nothing but the water contents. Okay. So, let us understand here the first meaning, liquid limit. What do you mean by liquid limit? Now, see students, it is quite simple. What do you mean by liquid state? How can you say that something is a liquid when it is not offering any shear resistance, easy to flow? That when it is easy to flow, when it is having no shear resistance. So, what is the liquid limit means? It is the minimum water content at which soil has small shear resistance. Because if it crosses the liquid limit, it behaves as a liquid. That's what I would like to tell you. If you see the graph here, if you cross the liquid limit, then it is liquid state. So, what do you mean by liquid limit is, it is the water content. It is the water content. Liquid limit means it is the water content at which the soil has, it is the water content at which the soil has small shear resistance, at which the soil has small shear resistance against the flow. So, this is the definition of liquid limit. My dear students, let me tell you one more thing. Liquid limit is also defined in a practical way. A soil cut by a groove of standard dimensions will flow together for a length or for a distance of 12 mm under an impact of 25 number of blows. Is also how much minimum water content is required. That also we define as liquid limit. Again, I am telling you, the minimum water content at which soil cut by a groove of standard dimensions will flow together for a distance of 12 mm under an impact of 25 number of blows. That water content is also called liquid limit. And what is the apparatus used for liquid limit is Casgradus apparatus. What is the apparatus used for liquid limit to find out liquid limit is Casgradus apparatus. So, my dear students, let us conclude. What do you mean by liquid limit? It is the minimum water content at which the soil has small shear resistance. Now, let us go into the most important one, that is flow index, or you can say flow curve. Okay. Now my dear students, what do you mean by flow curve here is, if you understand, see students, now see students, a graph is drawn between water content and number of blows. What sir? A graph is drawn between water content and number of blows. Okay. Now let me tell you, if the water content is more, definitely you require less number of blows. Are you getting me or not? Because if the soil is loose, are you getting me? If the water content is more, you require to compact it very less number of blows. If the water content is less, you have to apply more number of blows to compact it. So see students, here if I assume it as water content 1, and here if I assume it as water content 2, and if you see the graph is somewhere like this. Okay, or you can write here number of blows as N1, and here you can write number of blows as N2. Now my dear students, if you know mathematics, see my dear students, if you know the straight line equation has y is equal to mx plus c. But let me tell you one basic thing, what you do in engineering. Sir, what do you mean by log 1? Amma? Log 1 is nothing but 0. Log 10 is 1. Log 100 is 2. Sir, what is the logarithm function will do is, for a larger value, the variation is small. So if the value is 1, here you are getting 2, 10, 1, 100, 2. So even though the variation is large, log 1000, it is 3. So when you apply a logarithm here, the values will be very close. Then you can make this curve as a straight line. Okay. Now are you able to understand what is a flow curve is? It is a curve drawn between water content and number of blows. Soil passing through, here my dear students, to perform this activity, soil passing through 424 micron sieve is used to understand the flow curve. Okay, here my dear students, I hope you are clear how a curve can be drawn into a straight line. By applying the logarithm, we can make a curve a straight line. Now see students, flow curve will give you, why do you want to study about flow curve is, flow curve will give you idea about the shear strength of the soil. What sir? It gives you idea about the flow curve gives you idea about shear strength of the soil. And remember my dear students here, the slope of flow curve, if you talk about the slope of flow curve, what do you mean by slope of flow curve? Slope of flow curve is nothing but flow index, right? Sir, flow index is something like a coefficient. Now see students, if you have a straight line y is equal to mx plus c, what do you mean by m here? The difference of y coordinates minus the difference of x coordinates, right? But here if you see this graph is a decreasing graph. More water content, less number of blows. Less water content, more number of blows. Hence here, if you see the flow index IF is given by the formula W1 minus W2 upon log A minus B, log N2 minus log N1. Log A minus log B can be written as log A by B. And remember, this will help you to have an idea on the shear strength of the soil. This will help you to understand about the shear strength of the soil. I hope you are clear. So flow curve gives you idea about the shear strength of the soil. Soil passing through 424 micron sieve is used in this test. And remember, the slope of flow curve is known as flow index, and this is how we calculate the flow index. Now let us go into the most important, like we have the next one we have is the plastic limit. Next one what, sir? Next point we would like to discuss here is the plastic limit. Now my dear students, what do you mean by plastic limit here? Sir, see, when you add some water into the soil and try to make a rope, and the rope should have some dia without any breaking, that is known as plastic limit. Means I'll tell you like this. It is the minimum water content at which a soil can be rolled into 3 mm diameter. Means you add some 5% water and make the soil of 3 mm diameter, it should not break. If you add 7% also, it should not break. Then 5% and 7%, which you will take it as plastic limit. That is the reason I am using the word minimum. So what do you mean by plastic limit is, it is the plastic limit means it is the minimum water content. It is the minimum water content. It is the minimum water content at which soil can be rolled into 3 mm diameter rope without breaking or without crumbling. Without breaking or crumbling. Now my dear students, you will ask me, sir, why you are giving all the detailed explanation of the definition? Because we are in a zone of multiple select questions. So you should have an idea of the definition. Without breaking or crumbling. So this is known as plastic limit. Okay. Now let us understand the next ATTERBERG limit is shrinkage limit. And remember my dear students, ATTERBERG limits are also known as consistency limit. Okay. Now see students, what do you mean by shrinkage limit? Sir, see, it is the minimum water content at which the soil is fully saturated. What, sir? What do you mean by shrinkage limit here is, you can write here, it is the minimum water content. It is the minimum water content at which soil is fully saturated. Now my dear students, you know one formula. If you know what is the relationship between void ratio, water content, specific gravity and degree of saturation, you know that E is equal to Wg upon SR. Now what he is telling, when the water content is minimum, that water content will become shrinkage limit. So water content minimum means shrinkage limit, but there is a condition here that degree of saturation should be equal to 1. If you apply this or plug in these values in the above formula, shrinkage limit can be written as E upon G. It can be written as what, sir? Shrinkage limit can be written as E upon G, a very, very important formula. So what do you mean by shrinkage limit? It is the minimum water content at which the soil is fully saturated. And this is the formula, my dear students. Now let me tell you one important thing here. If you see the ATTERBERG limit, if you see the graph, I have told you this is shrinkage limit, right? This point is shrinkage limit. Now see students, up to this limit, the volume remains constant. Are you getting, my dear students? Up to shrinkage limit, the volume remains constant. So there is another definition you can write. It is the maximum water content up to which, or it is the maximum water content at which further loss of moisture Any loss of moisture will not cause any change in volume. Are you getting, my dear students? It is the maximum water content at which any loss of moisture, further loss of moisture does not cause any change in does not cause any change in volume. Are you able to understand, students? So there are two definitions for shrinkage limit. One is the up to shrinkage limit there will not be any change in volume, or it is the maximum water content at which further loss of moisture does not cause any change in the volume is nothing but shrinkage limit. And if you see, it is the minimum water content at which the soil is fully saturated. And please remember this formula, my dear students. Shrinkage limit can be written as E upon G. Now let me tell you another important thing. What do you mean by shrinkage ratio? What do you mean by shrinkage ratio? What do you mean by shrinkage ratio is? Sir, first of all, shrinkage ratio will not have any units. It's a ratio. Okay. So what is shrinkage ratio here is, it is the volume change. Shrinkage ratio means it is the volume change. It is the volume change expressed in terms of dry volume. What's that? Shrinkage ratio means it is the volume change expressed in terms of dry volume. It is the volume change expressed in terms of dry volume. Expressed in terms of dry volume to the corresponding change in water content. Sir, what is the definition here? Actually, by the definition, you will understand how the formula will come. It is the volume change expressed in terms of dry volume to the corresponding change in water content. Now see, students, here I will draw the graph. Just to have an understanding, I am drawing the graph, student. Now see, students, if I assume this as shrinkage limit, this is plastic limit, and this is liquid limit. Now, whatever the volume at dry shrinkage limit will be Vd, and the volume at plastic limit is Vp, and the volume at liquid limit is Vl. So these are the volumes at different water contents. Now what is telling? Volume change expressed in terms of dry volume to the corresponding change in water content. So my dear students, you can write it as shrinkage ratio as VL minus VD by VD upon, what is the water content at liquid volume? WL. Dry volume, it is shrinkage limit, WL minus WS. Or you can write it as Vp minus Vd upon Vd upon Wp minus Ws. Or you can write VL minus Vp upon Vp upon Vd upon WL minus Wp. Now see, students, this is the formula for shrinkage ratio. And another important thing, let me tell you, shrinkage ratio is also defined as the mass specific gravity at dry state. What, sir? Shrinkage ratio is also defined as mass specific gravity. It is defined as the mass specific gravity at a dry state. So this is also a very important formula. Okay, see students, if you want to understand here, let me tell you, shrinkage ratio can be written as gamma d by gamma w, that is equal to mass specific gravity at which state, sir? At a dry state. This is the another important definition of shrinkage ratio. Now, my dear students, do you want to understand what is shrinkage limit? Shrinkage limit is also given by the formula 1 by Gm minus 1 by G. This is also an important formula, my dear students. So here, what do you mean by shrinkage limit? What do you mean by shrinkage ratio? It is the volume change expressed in terms of dry volume to the corresponding change in water contents. Shrinkage ratio is also defined as the mass specific gravity at a dry state. So these are the important things related to shrinkage ratio. Now coming to the volumetric shrinkage. What do you mean by volumetric shrinkage? Any idea, my dear students? What do you mean by volumetric shrinkage? Do you have any idea about the volumetric shrinkage, students? Now see students, volumetric shrinkage is nothing but the volume change expressed in terms of dry volume. So here what do you mean by volumetric shrinkage? It is the volumetric shrinkage is nothing but the volume changed expressed in terms of volume change expressed in terms of volume change expressed in terms of volume change expressed in terms of dry volume. Volume change expressed in terms of dry volume is nothing but what, sir? Is nothing but volumetric shrinkage. Or you can write here VL minus VD by VD can be, this is nothing but, this part is nothing but volumetric shrinkage. Now this can be written as shrinkage ratio into WL minus WS. Sir, this is also VP minus VD by VD. This also you can write it as shrinkage ratio into WP minus WS. So all this is also called as volumetric shrinkage. Are you clear, my dear students? Okay. Now see students, what do you mean by, let me tell you the things here. Okay, we have another important concept is important indices. Important indices. What are the important indices we have is the, first one we have is the plasticity index. Actually, my dear students, in classification of the soil, to understand whether it is a fine grained or a coarse grained, you should have an idea on the important indices. First one we have is the plasticity index. First one what we have, sir? First one we have is the plasticity index. What do you mean by plasticity index here is, plasticity index is given by the formula IP is equal to WL minus WP. This is a very, very important formula. What is WL here? Liquid limit. What is WP? Plastic limit. Now see students, if IP value is 0 or negative, negative will be also treated as 0 only. Even though it is negative, you treat IP value as 0, then we say that the soil is non-plastic. Then we say that the soil is non-plastic. And remember, my dear students, if IP value is less than 7, If IP value is less than 7, then it is called low plastic. If IP value is less than 7, then it is what, sir? Low plastic. And remember, my dear students, if IP value is between 7 to 17, then it is medium plastic. Sir, what do you mean by plasticity? A property of the soil which will deform without any rupture, you can say. And if the IP value is more than 17, then it is highly plastic. Okay. So this is all about the plasticity index. So my dear students, what do you mean by plasticity index is? It is nothing but the difference between liquid limit and plastic limit. Why do you want to study about plasticity indexes? In the plasticity chart, it will help you to understand how can you classify a soil. If you want to have an idea on group index, or if you want to have a how do you classify the soil in soil classification related to plasticity chart, this will have an impact. Okay. Now coming to the next one we have is the shrinkage index. Shrinkage index is denoted as IS, and it will tell you about the shrinkage characteristics of the soil. WP minus WS. Shrinkage index is given by the formula WP minus WS. What is WP? Plastic limit. What is WS? Shrinkage limit. Let me tell you one important thing here, students. If you talk about the graph here, I have shown you the graph here like this because there was one time asked in a IISm this question. This was WS, WP, and this was WL. They can ask you what is the increasing order of the water contents here. Now if you see a graph, when you move to the right direction, how do you number it, sir? 1, 2, 3. That itself says that liquid limit is, if they ask you what is the order of ATTERBERG limits is, liquid limit is greater than, plastic limit is greater than, shrinkage limit. You can say here, this is the order of the ATTERBERG limits, or order of ATTERBERG limits are also called as what, my dear students? They are also called as consistency limit. Students, if you have any queries, you can ask me, okay? And remember, my dear students, don't forget to like, share and subscribe the channel if you are interested to have more updates on any one of the topics, okay? Now here, what do you mean by shrinkage index? It is the difference between the plastic limit and the shrinkage limit. And here liquid limit is greater than, plastic limit is greater than shrinkage limit. And the order of the ATTERBERG limits are like this, okay? Now let us understand what do you mean by toughness index? What do you mean by toughness index? Here, see students, toughness index, if you talk here, it is denoted as IT, and it is defined as the ratio of plasticity index to the flow index. What, sir? Toughness index means how hard the soil is. Okay. How do you know the toughness index value is? It is the ratio of plasticity index by flow index. And you know, my dear students, IP is given as what, sir? Liquid limit minus plastic limit. And flow index, how do you know? It is given by the formula W1 minus W2 upon log of N2 by N1. So this is what do you mean by toughness index. I hope you are clear. Any doubts in this, students? Now, do you want to understand what do you mean by consistency index? What do you mean by consistency index? Now see students, consistency index is denoted by IC. It is given by the formula WL minus W upon IP. Remember again and again I am telling you, all these indices are helpful to classify the soil. Okay. Consistency means it is the property of the soil which resists against deformation. It will not allow the soil to deform. So that is nothing but consistency. Here a consistency index is IC is equal to WL minus W upon IP. Now my dear students, at liquid limit, consistency will be, index will be equal to 0. At a plastic limit, consistency index will be 1. And at shrinkage limit, consistency index is greater than 1. It is as simple as this. You know already that liquid limit is greater than plastic limit is greater than shrinkage limit. Here you already know what is IP, WL minus WP. Suppose see students, in the first case, at liquid limit, water content will become WL there. So it will be 0. If it is plastic limit, WL minus WP is nothing but IP. IP upon IP is 1. If it is at shrinkage limit, numerator is greater than the denominator, then definitely it will be more than 1. Similarly, to understand the state of the soil, we also have liquidity index. We also have what, sir? Liquidity index. And liquidity index, if you represent here, IL is equal to W minus WP upon IP. Are you getting, my dear students? Now, IL will be equal to 1 at liquid limit. IL will be 0 at a plastic limit. IL will be negative at shrinkage limit. Okay. This is all will help you to classify the soil in the fine grain. Agree, my dear students? Now, do you want to know what do you mean by IC plus IL? Now, let me tell you what do you mean by IC plus IL. Okay. You know what is the formula for IC? It is nothing but WL minus W upon IP. And what is IL, sir? W minus WP upon IP. Okay. Here, my dear students, minus W plus W cancel. WL minus WP is IP. IP by IP, that will be equal to 1 or 100%. Here, please understand, my dear students, IC plus IL is equal to 1 or 100%. IC plus IL is nothing but what, sir? This can be written as 1. If they ask you in percentile, it will be 100%. And if they ask you in values, it will be 1. Now, let us understand, my dear students, let me tell you the entire what we studied in the ATTERBERG limits before going to the next point. Okay. First, we have liquid limit. Okay. Liquid limit is greater than, plastic limit is greater than shrinkage limit. Okay. We have studied about flow index. That is IF is equal to W1 minus W2 upon log N2 by N1. I am telling you the important formula. And if I talk about shrinkage limit, it is given by the formula E upon G or 1 by Gm minus 1 by G. Okay, this is shrinkage limit. Okay. Now, what do you mean by shrinkage ratio? What do you mean by shrinkage ratio? Shrinkage ratio is nothing but the mass specific gravity in which state, sir? In dry state. Shrinkage ratio is nothing but the mass specific gravity in dry state. Shrinkage ratio is nothing but the mass specific gravity in dry state. And remember volumetric shrinkage. If you talk about volumetric shrinkage, it is nothing but the volume change expressed in terms of dry volume to the corresponding change in water content. To the corresponding change in water content is nothing but volumetric shrinkage. And we have different indices like IP is equal to plasticity index is WL minus WP. Shrinkage index is equal to WP minus WS. And toughness index IT is equal to IP upon IF. And we have consistency index is equal to WL minus W upon IP. And IL is equal to W minus WP upon IP. Just go through this for a minute, students. One second. Just go through this slide for a minute. If you have any queries related to this, you can ask me, students. I hope you are written this, students. Now let me go into the next important point, that is activity ratio. What, sir? Activity ratio. Sir, why do you want to study about activity ratio? Tell me. The swelling and shrinkage characteristics of a soil are represented by a number called activity number. Swelling means nothing but bulging. Shrinkage means volume reduction. So here see, students, swelling and shrinkage characteristics. Swelling and shrinkage characteristics and shrinkage characteristics of a soil. Swelling and shrinkage characteristics of a soil are represented by activity number N. By activity number N. Clear, my dear students? Why do you want to study about activity ratio? The swelling and shrinkage characteristics of a soil are represented by what, sir? Activity number. Now, my dear students, what do you mean by activity number is? It is defined as the ratio of plasticity index to the percentage of clay fraction. Activity ratio is defined as what, sir? It is defined as the ratio of plasticity index. What is IP? Plasticity index to the percentage of clay fraction. Here what I will write to tell you is percentage of clay fraction. My dear students, they can give you another way also. Soil passing through 2 micron is nothing but clay. A soil passing through 2 micron to 75 micron is silt. Percentage of clay fraction. Again, I would like to tell you, my dear students, activity ratio is defined as the ratio of plasticity index to the percentage of clay fraction. The swelling and shrinkage characteristics of a soil are represented by a number called activity number. Now, my dear students, if activity ratio is less than 0.75, then it is having low active. What do you mean by low active? Means it will have less swelling and less shrinkage. If the activity ratio is between 0.75 to 1.25, then we call it as medium active. Then we call it as what, sir? Medium active. And if the activity ratio is more than 1.25, then it is highly active. Then it is what, sir? Highly active. So here, my dear students, based on low active means low swelling, medium active means medium swelling and shrinkage, high active means high swelling and shrinkage. So remember again and again, my dear students, activity ratio is defined as the ratio of plasticity index to the percentage of clay fraction. It tells you the swelling and shrinkage characteristics of the soil. And let me add you one more point. Black cotton soil has an activity ratio which is more than floor. Montmorillonite has activity ratio which is more than 4, not black cotton soil. Montmorillonite is having more than 4. If you tell C students, if it is more than 1.25 itself, it is highly active. Imagine if it is more than 4 means it will be having high swelling and shrinkage. Now, my dear students, let me go into the example. A clayey silty soil has a silt content of 70 percentile and liquid limit is 40 percentile and a plastic limit is 10 percentile. I am just framed the question on the fly. Now what he is asking is calculate the activity ratio. Calculate the activity ratio of the soil. I will give you 1 minute of time, students. So here again I would like to tell you the question. A clayey silty soil has a silt content of 70 percentile, liquid limit is 40 and plastic limit is 10 percentile. Calculate the activity ratio of the soil. Please solve this problem, student. Please solve this question, students. Okay, I have given you enough time, sir. Now let me go into the question. Now most of the people will solve this wrong. Now most of the people will do this wrong. See, they have given silt content is 70 percentile. If you see the solution here, silt content is given as 70 percentile. It is a clayey silty soil. Now my dear students, if silt is 70, then clay will be how much, sir? 100 minus 70, then it will be equal to 30%. So here you should be very careful. You should not write blindly that clay, if they give you the silt content 70 and take that 70. It is actually clay content is 30 only. Now what do you mean by activity ratio, students? It is the ratio of plasticity index to the percentage of clay fraction. What is plasticity index there? Plasticity index is nothing but liquid limit minus plastic limit upon percentile of C. Here liquid limit is what, sir? 40 percentile. Plastic limit is 10 percentile and clay fraction is 30 percentile. If you calculate this, activity ratio will be equal to how much? Activity ratio will be equal to how much, sir? It will be equal to 1. Now tell me, sir, whether it is medium active or low active or highly active. Based on the table, if it is less than 0.75, it is low active. If it is between 0.75 to 1.25, it is medium active. So the answer here is medium active. I hope you are clear with the content of the ATTERBERG limits. Let us quickly revise. What are ATTERBERG limits? These are the water contents at which soil passes from one state to the other state. Liquid limit means it is the minimum water content at which the soil has small shear resistance. Shrinkage limit means it is the minimum water content at which the soil is fully saturated, or it is the maximum water content up to which any further loss of moisture does not cause any change in volume. And what do you mean by plastic limit means it is the minimum water content at which soil can be rolled into 3 mm diameter without breaking or crumbling. Now what do you mean by shrinkage ratio? It is the volume change expressed in terms of dry volume to the corresponding change in water content. And shrinkage ratio is also defined as the mass specific gravity at dry state. And let me tell you the important thing, what do you mean by volumetric shrinkage? It is the volume change expressed in terms of dry volume. And we also have studied about the important indices. Plasticity index is liquid limit minus plastic limit. Shrinkage index is plastic limit minus shrinkage limit. Toughness index is IP upon IF. And liquidity index is W minus WP upon IP. Consistency index is WL minus W upon IP. Consistency index plus liquidity index is equal to 1 or 100 percentile. And we have studied about the activity ratio. It is the ratio of plasticity index to the percentage of clay fraction. The swelling and shrinkage characteristics of a soil are represented by a number called activity number. Why you want to study about this? To understand the swelling and shrinkage. Montmorillonite has the highest activity, that is greater than 4. Now, my dear students, what we do at IMS Gate Academy? IMS Gate Academy offers 800 plus hours of gate coaching. We provide online, offline and self-recorded gate coaching. And remember, my dear students, we have come up with a gate question booklet with 34 years of solutions. It contains alternative solutions, key pointers, and for the difficult level questions, we are coming with the video solutions. Very good, Arvind, very good. Good answer. Now, my dear students, we at IMS Gate Academy offers you the chapter-wise material, subject-wise material, and we also covers 130 plus tests, which covers chapter level test, subject level test, advanced level test, multiple subject tests, and we also cover the All India mock test, which will be replica of the GATE environment. Apart from this, if you want to, the main key success for IMS GATE Academy is the one-to-one mentorship, where we identify the strength and weakness of the student and how the weakness can be converted into strength. We also discuss the entire roadmap for the GATE preparation for the entire year. In addition to this, we also provide doubt solving portal where the doubts can be resolved within 24 hours of time. Now, my dear students, whoever qualified for the GATE, and if students, I have heard from some of the students who are from other branches are also writing computer science and DA and all. Please try to join the Telegram group. If you want to have any queries related to the post-GATE guidance for GATE 24, we have already uploaded the videos. But still, if you have specific queries, our mentors are ready to help you. We will help in every aspect for the post-GATE guidance. I hope this video will create an awareness on the ATTERBERG limits concept. Thank you and all the best.